this is the topology where we are going to implement the most basic of site-to-site example of IPsec. Alright. So before we start doing any practical of IPsec, we should have three things handy. Three things we must have before starting any configuration of a VPN. That is ISACM policy, ISAKMP policy. Then second thing is IPsec policy. At this point you should be recalling that thing, that ISACM policy equal to phase 1, IPsec policy equal to phase 2. And interesting traffic, it is also called as crypto ACL or VPN traffic. Many books are referring many things. So these two, IPsec policy and interesting traffic, is consisted of phase 2, whereas ISACM policy is equal to phase 1. Okay, so we must have the values before starting the configuration. So ISACM we are going to use, let's say 3 days as an encryption algorithm, SA as a hash algorithm, authentication we are going to use as a preset key, and the preset key that we are going to use is Cisco 123, and diffie element group we are going to use 2. So these 4 elements, 3 days, SA, preset key and DS, it is called the elements of ISACM. So which consists the ISACM policy. Okay, IPsec policy is the this ISACM policy is going to be used for the key protection, not your data protection. Okay, once the key is being exchanged and everything phase 1 is being completed, now the second part is to protect your actual data. So in actual data protection you are going to use, let's say, AES 128 bit with 128 bit of a key, SA as a hashing algorithm, or let's say let me take it different only so you can have the clear understanding that these two does not need to be having the same value. Okay, and you are going to use ESP as a transport protocol. Now interesting traffic, if I am at R1, I will say that if traffic is going from 1.1.1.1 to 2.2.2.2 and coming from 2.2.2 to 1.1.1.1, it should be the VPN subjected traffic. Alright, so if the same value must be there at the R3 side as well, but this ACL should be reverse, it should be the mirror image. Okay, so let me initialize and assign the IP addressing on this routers. We will again resume this recording. Alright, so I have assigned the IP addressing on all the routers and given the routing information as well. So let's check on R1. According to our diagram, FA0/0 should be having the IP address 30.1.1.1. You can check it, 30.1.1.1 is on FA0/0. It is also having loopback 1.1.1.1. Why we are taking loopback 1.1.1? Because it is your internal router, internal network, or you can say this is your private network. Okay, so we are not taking another router, but we are just saying it is a loopback only. So when we try to have the communication, VPN communication, we will source the packet with this address. Okay, and we will not source the packet from this one. And I also said that default route you send it to 30.1.1.2. Why did I give like this one? That I will explain when we reach up to that point. Okay, so check on R2 as well. On R2, show IP interface brief. See, FA0/0 is connected to router 1, 30.1.1.1 is the router 1. You have the reachability, and at router 3 the IP address is 20.1.1.3. You have the reachability. If you check the routing table, you don't have any other routing information, then this R2 will be acting as a internet router who does not know anything about the private network or who doesn't have any private network. Okay, so you don't have to have the routes for 1.1.1 or 2.2.2 network. Let's check the R3 configuration. So IP interface brief, it is having one private network 2.2.2.2 and one public IP address 20.1.1.3. If you try to ping internet, let's consider this R2 as your internet and the internet gateway is 20.1.1.2. Okay. So now at, let's say R1 is you and you want to configure the VPN at R1 first. You can configure from any site. But what are the things that you have to keep in mind before or starting configuration? These values must be first designed and considered. ISACM policy, IPsec policy, and what is the interesting traffic. Okay, so let's create the ISACM policy first. And along with this one, you also must have the information about who is your VPN endpoint. Means this guy's IP address you must know where you are forming the VPN tunnel. You know that you are going to source every VPN packet on or from 30.1.1.1, but who is your destination of VPN tunnel? That's why I draw this diagram, right? Tunnel source from here destined to 20.1.1.3. So in our case it's 20.1.1.3, right? Okay, go to R1. Let's define the ISACM policy first. Let me try to squeeze it a little bit. If you can see, yeah, that looks better. ISACM policies. How to define the ISACM policy is crypto ISACM policy, and you give some number. What is the significance or the importance of this number is you can define 10,000 policies in one router. Now it does not require that you always use the same policy for all 1,000 tunnels. You may use different policy for different tunnels. Okay, so to use the different tunnel and to use the different policy for different tunnel, you have to specify these policies by giving the different sequence number. The search order of the policy will be lowest will be first, then it will go the higher one. Let's say if you are defining 1, so this policy, whatever you are writing under this policy, will be searched first. If someone is asking you the tunnel, we will see again. So see, the command is also intuitive. It is saying it starts with the encryption. What is the encryption you have taken? 3 days. Authentication. What authentication you have taken? Authentication. Preset. Then hashing. Diffie-Hellman equal to, you have to take over here as a group. They are not saying like DH group. They are not saying as DH group, but just group. And see, when you put the question mark, it is Diffie-Hellman group actually. So what we have taken over here? 2. So in your practice, make sure that you are using these values. So crypto ISACM policy will display the policies you have configured. So crypto ISACM policy, you make sure that you have the same set of security association for the ISACM defined at the other side. Same. If any of this value is mismatching, phase 1 is not right. Now you are seeing over here this default protection suite. That is default. If you do not configure this one, this is the default one. Under the default one, authentication type they are using as a signature. So for the signature, we have to go for another kind of another concept. We have to learn another thing that is called PKI, public key infrastructure, that we will see in the further classes, and we will use the default one for our testing. Okay, but as of now you just consider this is the policy just now we had configured it, right? So at this point at R1 we have configured the ISACM policy. Okay, the policy is not completely configured yet. The reason is we said that authentication we are going to use as a preset key. So we have to define the preset key first. If we are using the signature, then we must have the signature or certificate installed on this router. So policy is not complete. ISACM policy is not complete until and unless you fulfill all the requirement. You have fulfilled the requirement. 3 days SA and DS group you have said it. But still you have to define this Cisco 123. So how to define it? Crypto ISACM key. Let's say Cisco 123 address. Actually you can type it like this one, Cisco 123 address 30.1.1. It's a 20, right? Not 30. you can type like this one, but why this,
07 key.
why it is not saying that contested sensitive is not saying, because yeah, it is saying that where you want, how you want to encrypt this key locally. Okay, it is nothing to do with the VPN thing. It is in the running configuration how you want to encrypt it. It's nothing to do it. Let's say 0 means I want to put it plain text, I don't want to encrypt it. So when I do the show running, it should display it on the show running. So let's say this is the key, and then address. What is your address? I mean, what is your VPN endpoint? So that's what you are typing over here. If this guy is coming, you have to read this command like this one. If someone is asking the ISACM tunnel, and if he is presenting Cisco 123, or in other word, if he is coming from 20.1.1.3, he must have Cisco 123 as a ISACM key, preset key. Okay. Yeah, actually we have executed this command. No? Okay.
So by default it takes 0.
Yeah, by default it takes 0. So that is called crypto ISACM policy. This is the policy. Now to check the preset key, crypto ISACM key. So this is your phase 1 is completed. Okay, phase 1 is completed. Now you can start with the phase 2 configuration. So before you start the phase 2 configuration, first you should define the access list. First you should define this interesting traffic. So let's define it. Access list 101 permit IP. Let's say it is only one host. We are not saying network to network, but you can also define network to network. Okay, or any to any. Let's say 1.1.1.1 host 2.2.2.2. So it is the another use of access list. We also have used the access list for another use. Let's say classification of the traffic. This is also one type of classification. You are not filtering the traffic just by using the access list. You are not applying that access list onto the interface, but you are using that access list for some other purpose, not for the filtering purpose, but for the classification purpose. Now this is called the interesting traffic defining. It is been done, right? Now you have to integrate it into the IPsec. Now you can define the phase 2 parameter, crypto IPsec transform set. You give the name, any name you can give. Let's say R1 to R3. I am saying that ESP is the protocol I am going to use. 3 days is the algorithm, encryption algorithm. ESP is the again protocol, and I am going to use SAR, right? What we have said? No, MD5. MD5 we have used. Now many of you might be having the question that what is HMAC? It is a HMAC authentication code. What is the function of it? We will see 2-3 VPNs, and then we again delve into the small things. Okay. Now, as of now, everything is prepared. Phase 2 is prepared, access list is prepared, phase 1 is prepared. Now you have to relate all these things together and put it into the operation. So that's where come one more thing, that is called crypto map. There is something called crypto map which will bind all this together, and you can apply crypto map onto the interface. The moment you apply the crypto map onto the interface, your VPN is started. I mean the engine is started, or engine is like, you did not start the process, but the engine, the capability is started. So you create the crypto map.
So after the crypto IPsec transform set, we have completed phase 2, right?
Yes.
For encryption we have taken AES.
Yes, we said it wrong actually. Let's remove it. ESP AES 128 ESP MD. Yeah. So you have to create the crypto map. Let's say R1 to R3. Sequence number ISACM. It says that I am creating the crypto map. What is the type of that crypto map? It is IPsec ISACM is a type. you have another type of the crypto map that is called GDOI. That is another type of VPN. We are going to learn about it. So as of now, we are not going to use any other type, but whatever we have learned, that IPsec and ISECM, that type of crypto map we are intended to create it. Okay. Over here, if this crypto map is being started, what is the end peer, or else who is your remote peer, that you have to first configure. So you say that set peer. What is the IP address of your VPN end? I mean other end. What is the IP address of it? 20.1.1.3. Or else crypto ISECM key, I think, right? So crypto, yeah, you have to make sure that in the setting peer, set peer command, these two address must be same. If you don't know about this one, you just execute this command, do so crypto ISECM key, and check that what is the end peer IP address you had executed in the previous way, and you can type it over here. Okay, so set peer you have configured. Now you have to relate that IPsec phase what we have created, transform set, right? What was the name of it? R1 to R3, right?
So R3 capital letter.
Let's see. So crypto IPsec transform set. So you don't have to, just you should be knowing how to execute or how to get the particular information. That's it. Set transform set R1 to R3. Okay. And now you have to relate that what is your interesting traffic. So match address. What was the name of it? 101. So let's review the complete thing. So running configuration pipe section crypto. Let me make it bit. Okay. See here. You have created this particular configuration. This particular configuration is dealing with the phase 1. Okay. This particular line in your access list is dealing with phase 2. This is something which is matching up all these things, who is binding all together. Crypto map is binding all together. So if any traffic is coming from 20.1.1.3, okay, so he will start searching inside this router that who is the whatever ISECM policy you are offering, that guy is offering the ISECM policy. Do I have this configuration in me? If yes, then let's go further and do the negotiation of the further phases. If not, break the communication. Okay. Now the final piece is where you want to start this VPN. What is your exiting interface, or what is your VPN, or where exactly the VPN tunnel is supposed to be terminated. So here we are taking FA0/0, right? So go to FA0/0 and crypto map. What was the name? R1 to R3, right? It was small. So the moment you apply it, now this router is capable of listening or sending any cryptographic traffic, IPsec traffic. R1 is configured. Okay. Now same thing you have to configure on R3. So the best practice when you are doing for the first time, execute this command, so run pipe section crypto, copy all this into the notepad. If you are good at remembering, you can do it whatever the way you like, but first time you should do that way, like you should not make any mistake. Once you see the result by your hand, you will get more interest into the learning. If first practical is not working fine, you will never touch VPN again. So you copy this, make some changes wherever it requires. Where it requires, over here, first of all, that address should not be the 20.1.1.3, it should be 30.1.1.1, right? In the similar way, this address you copy and you set it over here. This command you have to remove it. Why? Because it is applied actually. This This last one is applied.
interface. So
Any
the map address access list.
yeah, access list will create. Yeah, anything else as of now over here?
Set transform set R1.
Yes, it's okay. The name can be same, no problem at all. You can define different name.
R3 also we have to specify that it is using that exit interface as.
No, we did not apply it. We did not apply it. We did not apply it. This is this configuration. Now we are going to apply it, this crypto map, to some other interface wherever we want to terminate it. Okay, we did not apply it yet. We are just talking about the values. Let's say this, most probably we are making the mistake in these values. Or maybe this should. Or maybe this one. So just to overcome those small minor errors, we are copying it. Once you are done with this one, just copy it. I am not saying this is a complete configuration. Still we have to configure something into it. First thing is the access list, right? Access list we did not configure yet. So we have to define the access list. 101 permit IP, and this time host should be what? Your local address, not the remote local address. So it will be completely different than what we had defined at R1. Okay, that was the last piece of configuration. Now you have to apply this crypto map onto the appropriate interface. What is the interface you want to apply it? You can check it. Let me minimize it. FA0/1 is the interface where you are expecting someone may initiate the tunnel, or someone may ask me to form a tunnel on this particular interface. Okay, let's go to interface FA0/1 crypto map R1 to R3, right? And you will get a message that crypto ISACMP is on.
So we give the same crypto map name.
Yeah, just we took it same. No, we just give the same name. It is not required. Actually, you can have any name. It is not required. Completely, it is not required.
So how we can see that the both, once you apply on the interface, both interfaces. So the tunnel engine is up.
Yeah, but they are not communicating at all.
So right now
No.
They have not shared any.
Nothing. It is not started. VPN process is not started. You are just done with the configuration. Okay. Now, when the VPN is starting, and what exactly the steps? See, we have learned so many things, right? ISACMP and this key exchange and that key exchange, and this will happen and this will be used. Now, see over here. So access list. It says that any traffic coming from 2.2.2 going to 1.1.1, classify it. This access list is saying that classify it. Now you see, so run section crypto. Okay. This access list 101 you have applied under crypto map, right? R1 to R3, under this one you have applied it. Means whatever the configuration is lying under the R1 to R3 crypto, it is subjected to be performed on this access list 101, or the traffic, or that packet. Okay, so packet was destined to what? 1.1.1.1. Okay, now if you don't have any route to send the packet 1.1.1.1, let's say you don't have this route. Okay, so first packet will check, or router will check the packet destination and source address. If it doesn't have the route, it will simply drop it. If you have a route, okay, then where exactly your next hop address is? 20.1.1.2, right? Where exactly the exit interface is? What is the exit interface in order to reach 20.1.1.2? FA0/1, right? Now, if you check FA0/1, it says that I have crypto map applied. Okay, so till then it hits the interface, VPN will not start. If route is there, route is saying that you go exiting, you exit out on this particular interface. If that interface is saying that I have something underlying me, then the whole process starts. Okay, so now let's initiate some traffic which is subjected to the VPN. What was your VPN subjected traffic? 1.1.12, 2.2.2.2, or 2.2.2.2 to 1.1.1.1. Since we are at R3, we can initiate the traffic ping 1.1.1.1 source 2.2.2.2. One packet is dropped and you got the ping. But there is nothing that you had seen so far. Whatever we have learned, you did not see anything else. But there are, I'll say, like bunch of messages has been exchanged and done. But before I will show this, I will clear it out, and again I will enable the debug and we will see it. But as of now, I can claim that it is a VPN subjected traffic. So how to first make sure that your phase 1 is negotiated or up? So to check that, your ISACM tunnel, bidirectional tunnel, show crypto ISACM SA, and it will show you who was the source, who has initiated the connection, who was your VPN endpoint, what is the state of the ISACM tunnel. So when you see that QM mode, QM equal to what? Peak mode, phase 2. So it has done, it has went, it has come, or it has passed through all along from phase 1. If it was phase 1.5, it has also been done, and it has reached to phase 2. In phase 2, QM quick mode has been performed, and now it is up. Okay. If you want to check phase 2, once phase 1 is up, the next step should be to check the phase 2. So in order to check phase 2, so crypto IPsec SA, you will say that number of what exactly you have to, or you should be looking is number of packet encrypted and decrypted. First packet went for the ARP resolution, right? No, here it is not ARP resolution, it is phase 1 negotiation. First packet, phase 1 negotiation. By the time they are done with the key exchange, first packet already timed out. Once they have the key exchange, they use the phase 2 parameters and they start encryption. Now if you ping, it will not miss any packet. And if you execute again this show crypto IPsec SA, you will see that packet have been encrypted. From where to where exactly it is encrypting? That is also called as a proxy identity. Okay, that is another name of crypto ACL is proxy identity. So in many books you will see that proxy identity. So don't get confused, or it is not big word. Proxy identity is source and destination IP address. Okay.
So one thing.
Yeah.
I do not understand why you applied the default route.
Sorry?
Default route.
Yeah. I'll explain. So let's say, so that's the working IPsec example. Now, some of you might be thinking that whatever we have talked so far, message, this message and that message and main mode and aggressive mode, and I want to see it practically, but you cannot see that this key is generated. This is the key. Now it is exchanging, but it will show you that which mode it is using, which is the message number, it will show you. So let's say I am clearing out all the VPN tunnels. So clear crypto session, it will clear both the phase 1 and phase 2. Okay, if you just want to,
Negotiation
it will clear out every single thing. No. The tunnels, ISACM tunnel and IPsec tunnel, tunneling clearance. Okay, so crypto ISACM SA, see, no state equal to, it has not started, or maybe the negotiation, phase 1 negotiation has failed. So since you have cleared out, so it will show for some time and it will remove the complete entry. At the same time, if you see, so crypto IPsec SA, there is nothing, right? But at other end it will be there. It is not going to go over there and say that okay, you also clear. So crypto IPsec SA, it is still there. So you have to clear at both the side. So clear crypto session. Now both are cleared, means again if you start the process, it will go through the phase 1, phase 2 and all message exchange, right? Let's see. Debug crypto ISACM, logging on, logging console. Don't try to understand every single message at the first shot. Whatever we have talked, whatever we have learned so far, you understand those many messages only. Then again you do the advanced practical, again you see and again you try to understand more messages. That's how the VPN will become very easy for you. Otherwise, if you see the bunch of messages, the moment we have enabled this debug, right, the moment we will start the process, it will show you many messages. But don't bother about it. One message you understand. Whatever we have exchanged, whatever we have learned so far, those messages, if you find the relative information about it, you just understand. You will understand it. Okay, whatever we have learned, that is this message. Don't be afraid of like what is SPI and what is this thing and what is that thing. We will learn about it. Go to R3. Again perform the same test. Okay. Go to R1 and see. It is behind the scene process. So once it is stopped, okay, I think it is stopped now. Okay, let's scroll it up and let's see. I am unable to go up to, sorry? Yeah, I am unable to go up to the starting of a process. But let's say, okay, actually it is the right place to start this first message.
Sir, it came proxy.
It was the first message. First message was actually good to show and start. By the time one message came and it went. The message was, you may stop the video, it is already recorded, so you may stop it and you can watch it, okay. So the message was MM and 1. So means main mode first message, okay.
So no problem, so you can show us main mode.
Yeah, I'll go. One second. Yeah, see, the first message was being received, okay, from R3. It was giving you the suites of ISACM, means what is the encryption, what is the S algorithm, group, and what is the type of it. Checking ISACM transform. ISACM transform is nothing but the ISACM policy, okay. They have used the technical word transform. So it is nothing but the ISACM policy against the priority 1 policy. Where you have, we have created locally over here, we have created policy 1, right? So it has started searching against the policy 1. See here, encryption 3 days, SA, authentication, SA is a default by the way. That's why it is written over here default. Group 2, authentication preset, and if it is matching to the offered one, if the guy who has initiated this tunnel, if it is matching, he will get this message. He will say that, okay, we are ready to go for message number 3 and 4. If this is not right, you will say that attributes are not acceptable. You can do this thing, you can do this practical, you change this policy, change one attribute and start doing again the same thing. Debug it, see it. You will get the message, attributes are not acceptable. So phase 1 will not up. If phase 1 is not up, phase 2 negotiation is too far. It cannot start. Now once the attributes are acceptable, it is starting the IK process mode is main mode, reply main mode, message 1, R means responder. Main mode 1 is completed. See over here, IK process complete. It's not complete process. The main message, main mode message 1 is being exchanged. New state is what? Message number 2. So that's how you will see all these things. Message number 3, 4. Protocol 17 equal to what? Protocol number 17 equal to what? Yes, exactly. And you will see port number, what they are using, port number, that also let me show you. See over here, receive the packet from 20.1.1.3. what is the port number?
500.
Okay, let's scroll it down and try to find some more information which you will understand. See, SA has been authenticated with 20.1.1.3. If there is a problem in your ISACM, you will get over here message SA authentication, the authentication status is not authenticated. So you have to, if you get this message, somehow you debugged it, you are doing some sort of the troubleshooting in a VPN. If you are over here at this point, if this message is there, you go further and check the phase 2 parameters. If this is not there, don't think about the phase 2, don't think about the access list, don't think about the transform set. Directly go to the ISACM policy, check it. Okay, set peer, you check it, key, you check it. See, once the phase 1 is complete, you will get the message phase 1 is completed. Once you see this message, make sure that okay, everything is done. Phase 1 I don't have to touch. Now I should check about what? Phase 2. If you don't see this message, see, once the phase 1 is completed, what is the message? What was the message previously? ISACM proposal, ISACM transform. Here it is a IPsec. So you have to have this clear understanding that ISACM is a phase 1, IPsec is a phase 2. IPsec equal to data, ISACM equal to key exchange. Okay. So now if it is using ESP, AES and the SA and MD5, whatever you have configured, you will get the message again over here. Attributes are acceptable. Okay. So once this is also acceptable, see, IKQM is ready. Now I have to establish session, or I have 3 actually total SA. One is ISACM SA and 2 are IPsec unidirectional. One I am sending for the encryption traffic, one I am receiving encrypted traffic. Okay. But as I said that, let's say again, so crypto ISACM SA up, so crypto IPsec SA, you are getting the encryption and decryption, right? Now, as I said that, if you want to have this IPsec, if your IPsec, this 2 SAs, unidirectional 2 SAs is up, you don't require this phase, or you don't require this tunnel, ISACM SA. So when I type that so crypto IS SA, it means so crypto ISACM SA. So if I delete this one, my communication will not break. Why? Because I have already exchanged key with me. If the validity of that key is over, then I cannot do.
Lifetime?
Yeah, lifetime is I think by default. Let's see. So crypto IPsec SA. How much? 1 day I think.
86 or 4 seconds.
It's 1 day I think. 86,400 is 1 day I think.
I think we can set it also.
See, lifetime you have 3069. It is 1 hour, right? 3600 means what?
Remaining key lifetime.
Yeah, I know that. It is like 3600 means what? 1 day? 1 hour? Yeah. So up to 1 hour, this key is valid. Actually, are we talking right only, or what? Is it the 36 equal to 1 hour only? Sure? Yeah, 1 hour. Okay. So this key is only the phase 1 key. The key which you have negotiated over the phase 1 tunnel. Which tunnel? This tunnel. This tunnel, whatever you have exchanged over this tunnel is valid for 1 hour. That I will tell. That again, the small things. Kilobyte means this tunnel you can have the validity set up based on the amount of traffic. Based on the amount of traffic, or you can have this based on the time validity. Okay, so once this time is over, again this key will be invalid. So if you want to extend that time, so I'll say this one, up to this time is valid, you don't need this tunnel. You can clear it. See how to clear it. Clear crypto ISACM. That's it. Clear, right? Clear crypto ISACM.
The ID one.
No, actually it's okay, but it will clear all the ISACM. We have only one, right?
Yeah.
Let's check it. So crypto ISACM base. No.
1, 2, this 1, 2 we define when we have more than 1 or 2.
No. When you have more than many people initiated the tunnel or responded the tunnel, and you have up tunnels, that time which tunnel you want to tear down? Which connection you want to tear down? Yes.
That purpose we use that.
Yes. Let's see. Ping 2.2.2.2 source 1.1.1.1, right? So crypto IPsec कैसे? Packet have been encrypted again and incremented. Now let's check your tunnel. Is it up? It's not up. We have deleted it. We don't require it. ISACM does not play any role in IPsec tunnel. But in order to form that IPsec tunnel, you must have the ISACM. Once the tunnel is up, and if it is into the valid time, you don't require it. Okay. So that was the most basic. Now you can do the debug thing and you try to understand each message. I mean, whatever you know, whatever we have learned, those many messages you just try to learn. Okay. You don't push your brain too hard to understand something we did not cover. If whatever we have covered this much, if you can understand, I can say that you will be like, damn good in the end of the VPN session.
Sir,